learning about arithmetic sequences. I think this is something y'all will enjoy, and it's something that is great to kind of kick us off with this particular lesson in general with Algebra 2. It's pretty straightforward. The good news is you can use common sense, so hopefully you won't have too many issues with this one. So arithmetic sequences. So looking at this first set of examples, think about what the next term in this sequence would be. Okay, so looking at the first one, if we notice we are adding 2 each time. So the next term in our sequence should be 9. Next one, it looks like we're adding 10 each time. So it looks like our next term should be 40. And it looks like we are adding a negative 5. So this one's a little bit different because we might want to say that we're subtracting 5 each time. So then if we subtract 5 again, we're at negative 10, or it's kind of making it a little funky. Okay, so with that being said, if you notice, we have a tendency of doing the same thing each time. We're adding 2, we're adding 10, we're adding a negative 5. So what does that mean exactly? So that is exactly what a arithmetic sequence is. You have what's called a common difference. So if you notice, we were adding the same number each time. We could add to get to the next number, but it would have to be the same exact number each time before we can call it an arithmetic sequence. So if you notice below, those are the same examples from the last slide. Our common difference is 2. For the first one, our common difference was 10, and then our common difference was negative 5. So we have a way of saying that we want to say that we subtracted 5, but in reality, we're adding a negative 5. So a way I like to remember this is that if I'm doing an arithmetic sequence, I'm adding. Notice how arithmetic sequence has an A, and so does added. So that helps you remember that. Okay, go ahead and take a couple of minutes and go ahead and find the common difference using the first term and the second term, and find the common difference using the third and fourth term, as that is misspelt. Again, we're still learning. Go ahead and take a minute and try and figure out what the common difference would be for each one of those examples. These are just methods of how you can figure it out if you can't see it as you go. Okay, so let's look at the first one. If we notice that we are adding by 3 each time, my common difference is going to be 3. I'll look at the next one. I notice I am adding 6 each time, so my common difference is just 6. The next one, it looks like I am subtracting, but I still have a common difference, but it's of negative 4. And the last one, like I said, if it becomes an issue where you can't figure out what you're adding by, you can always go backwards and say, okay, well, what's 3 minus a half? That is 2.5. And if we remember how to change those to improper fractions, that is 2 times, I figure out a way to show y'all, 2 times 2, which is 4, plus the 1 gets me 5 halves. So then if I take 8 plus 5 halves, and the reason why I'm going the longer way of this, when y'all get to pre-cal, you're going to need to know how to use fractions. I know y'all love them, but you're just going to have to learn how to use them. So it's best to start using those practices, especially without a calculator. So if I change 18 to 16 over 2, plus 5 over 2, 16 plus 5 gets me 21 over 2. And that's my common difference. Okay? And again, make sure on your notes that you are putting next to any examples that you are still wanting to ask questions about or have further questions that you want to have answered during office hours. Please make sure you're making note of that on your notes. Okay, let's move on. So looking at these examples, we look at the first example and we notice that we are adding 10. We're adding 10, we're adding 10. So this one is an arithmetic sequence. We notice on this example, we added 0, then we added 1, then we added 1, then we added 2. So that is not an arithmetic sequence. It is a sequence, but it's not arithmetic. And then the last one, if you notice, you add 1, and then you add 1, but then you add 2. So you might want to make sure that you always check every single part of the sequence to make sure that you are not just saying, oh, I saw the first 2, and I'm assuming that the pattern is the same the rest of the way. So this one's also no. So this is a new notation that you will need to get used to. Every year my arrows are off, and every year I forget to fix them. But if you notice, you're dealing with subscripts, okay? So you might hear me say a sub 1. That just means your first term. A sub 2, that's your second term. A sub 3, your third term, and so on. You'll use a sub n minus 1, a sub n, and stuff like that for the formulas you're about to do. But that's just their way of notating the first term, the second term, the 52nd term. You would just simply say a sub 52. That's asking you for the 52nd term. Okay. So it's just a new notation. Basically, the a sub n is the nth term we're looking for. A sub n minus 1 is the term before it, and a sub n plus 1 is the term after it. Again, our same examples here. If I asked you the question, what's a sub 2 in this case, you would just say 3. Or if I asked you a sub 4, you would tell me 40. Okay. So let me hide part of that. You don't need the directions down at the bottom. That's more for my CP level classes. All right, so go ahead and try these first 2 examples on being able to find the 8th term of the sequence. I haven't given you any formulas. If you notice, you have the first 4 terms, and you can simply just keep adding to find the 8th term. So go ahead and do so. So if you notice, you are adding by 4 each time. So if I continue to add 4, then I get 29 as my 8th term. Okay. So we're going to be looking at a formula that we don't necessarily have to keep adding for, that we can just plug in the first term, our common difference, and the term number we're looking for, and then we find our answer easily. Now, eighth term, that's one that we can keep adding. Like I said at the beginning, this could be something that we use common sense for. If you can't remember the formula or you don't know what to do, you can simply just keep adding. Even if it's wanting you to find the 150th term, just keep adding. Now, I would double check to count again to make sure that you added actually to 104 or whatever number that was. Okay, so if you notice, if I look at the next problem, I am adding 4 each time. And I would also suggest if you're someone that gets that you lose track of where you are, if you notice this is your 4th term, what if I said my 5th term, my 6th term, my 7th term, and my 8th term? So if I added 4, I would get 13. If I added 4, I'd get 17. If I added 4, I would get 21. If I added 4, I'd get 25. So that way, if I keep adding 4 and 4 and 4 in my calculator, and then I forget, well, hopefully you're not adding that in your calculator because it's just adding by 4, then you don't lose track of what number you are actually on. So we notice we get the formula by looking at something that has a lot of different ways of looking at this. Let's look at the actual formula itself. So if you remember, a sub n is our nth term. That could be me asking you for the 8th term, the 12th term, the 13th term, the 135th term, it doesn't matter. And that term number is also that n. So if I'm asking for the 35th term, then 35 will go in for n. Our a sub 1, we've already talked about, is our first term. And d is our common difference. Give you a minute to write that down. Also, at any time during the video, if you find yourself needing to write a little bit more than if I'm moving on too quickly for you, you can always pause it, get down what you need to, and then be able to move on, or you can take pictures and transfer it to your notes then after that. Okay. So let's try an example here, right? The first 4 terms of the sequence using the explicit formula. So you're going to see both the explicit and the recursive formulas and different things that you use. I don't use recursive formula as much because that formula is basically saying you take the term before the term you're interested in and you add the common difference to it. I know y'all can't see my face right now and my sarcasm over a video, but that to me says duh. So if I ask you for the 5th term and the term before it is 4, but the common difference is 3, then duh, you do 4 plus 3 and you get 7. So to me, the recursive formula doesn't really do anything for us because if I'm asking you for the 50th term, you must know the 49th term. Well, if you already know the 49th term, then there's no point in you using that formula because you just add the common difference. So let's look at this one. So I'm going to be picky when it comes to how y'all write these because we are no longer in Algebra 1 anymore. We're grown. But let's look at the formula for what we would use. So basically what I like to say is this formula is one that you could give to anybody in the world. And whatever term they want to know, they just have to plug it in for n and they're done. Okay, so let's use the formula. A sub n equals a sub 1 plus n minus 1 times d. let's fill in what we know. We know our first term, which is 4. We don't know n, and our common difference is 6. So if I distribute my 6, and then combine my terms, I have that basic formula that I need, 6n minus 2. That's what I'm looking for, okay? You will not get full credit. Oh, that was my shoe. You will not get full credit if you stop there or if you stop the line above it. So if it asks for the first 4 terms, a couple of different ways you can do this. You can either go ahead and start with your first term, which is 4, and keep adding 6 to it if you want to. Or you can plug into your formula. You can plug in 1, 2, 3, 4, and so on. And then that will simply get you your answers. So go ahead and try the next one. A lot of times what I'm going to do is I'm going to go ahead and start working out the problem. Feel free to continue just looking at your own paper and then look up to check as you go. So that way you're not just copying everything I do. It just kind of saves on time. Okay. As I forgot my n. So my a sub n, I get negative 3n plus 6. So if my first term is 3, but I'm subtracting 3 each time or adding a negative 3, I can go from there. Or if this is my first term, I can put a sub n equals negative 3 times 1 plus 6. Negative 3 plus 6 gives me negative or positive 3. Again, any questions you have, please make note of them so you can ask during office hours. Okay, so this is just a different way. If you notice, I'm flipping through the slides here. If you notice, I give you your first term and your common difference. The next way they could ask you is if they just give you the sequence. And you can find your first term and you can find your common difference as well. So it's just another way. If you need more examples, write those down and go through those. Same thing here. I can ask you the same information. I can give you the first term, the common difference. I need you to tell me the formula, but here I need you to tell me the 15th term. So let's look at those real quick. I take my formula. Hopefully you're doing this on your own. We have our formula, a sub n equals 12n minus 17. So this is what I was saying earlier. If anyone wants to know any term whatsoever, for instance, they want to know the 15th term, I can simply just plug in 15 for n. So 12 times 15 minus 17. Instead of continuing to add 12, add 12, add 12, add 12, which on a test, fight or flight, it really doesn't matter what you want to do with that. So if I add all that together, I get 163. Okay, go ahead and try the next one. Also, when you're on a test, seeing this work over here and how you got 163 versus this over here, and let's say I accidentally put 75, or I had a moment where I switched the 6 and the 7. If I don't have any work shown, I can't give you any credit for that. So make sure you're showing me everything you possibly can. Okay, same idea. Like I said, they can ask you in different ways where they give you the sequence versus the last slide where they give you the first term and the common difference, which they give you the same thing anyways. So if you need more examples, go ahead and knock those out. Okay, so we have the arithmetic mean or average of two numbers. So if I give you a sequence and I say 2 and then 6, so if I want to know what this part of the sequence is, we can assume, of course, that it's 2, 4, 6, because we know that one. Let's say we didn't know that. So I can take, this is x, this is y, so 2 plus y, or 6 over 2. So 2 plus 6 gets me 12 divided by 2, or 12. See, I'll still make mistakes too while videoing. 6 plus 2 is 8. Divided by 2 gets me 4. So if you notice, if that gets me 4 here, that's exactly the missing term. So that's how your arithmetic mean works. Also, if I make a mistake on the video that I don't catch myself on, please bring that to my attention so I can help anyone out that was maybe confused. Okay, so what if we have more than one blank in between two numbers? So if you think about it, realistically, I would have had to add the same number, which we called the common difference, once there, again, and then one more time. So I had to take 17, I had to add 4 common differences, so another way to say that is 4D, to get me 17. If you notice, I'm going to have to add nothing to stay with the same thing, but we'll see that if we subtracted our 17, our common difference would have to be 0. So then our sequence would continue from there. So notice the difference between what we were solving for on the last slide and what we're solving for here. Here, we're solving for our common difference. Over here, we've found the actual term, okay? So let's look at this one. I had to add my common difference once, twice, 3 times. So 0 plus 3 common differences got me 18. And if I divide by 3, I get a common difference of 6. So 0 plus 6 gets me 6, plus 6 is 12, plus 6 is 18. So I really like these because, you know, if you continue to add your common difference, if you don't get this number, then you did something wrong.
This is another way they can say it. Notice how this is our first term. They're asking you for the second term, the third term, the fourth term, and then this is our fifth term. So go ahead and try that one out. You notice my board's off a little bit. That's why it's kind of dragging at the end. That's 881. There we go. Okay. So they can also ask you this way, but if you think about it, it's something as simple as saying, well, if they give me my second term, which is 5, so it'd be 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th. But if you find yourself counting, you'll notice that between 2 and 15 is 13. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you can simply just subtract those two. 5 plus 13b equals 31. And you can figure out your common difference from there. And notice how the question is, they just want to know the common difference. They then could turn around and tell you or ask you what is the 20th term. So if you notice, if we found our common difference from there and then use that to then make our lives easier, our common difference is 2 for our formula, which is a sub n equals a sub 1 plus n minus 1 times d. We've got the common difference. We know our term number is 20. But our first term, if you notice back up here, it's a different color. That's our second term, but if we know our common difference, we can go backwards and say if our common difference is 2, then this must be 3. So then from there, we can easily figure out what our 20th term is. And that should be 41. If you notice, however, like I said, this is a big common sense chapter, that you're already at 15 over here, your 15th term. Well, you found your common difference, so you technically could just add 2 5 more times, which is 10, and add 31 and 10, you get your 41. But again, there's multiple ways of doing these. You can use formula, you can use common sense. Same thing here. I can give you a bunch of different ways to ask these questions. This one, they give you the first term, the common difference, and then a sub n. So if I set this up, let me extend my page. My first term is 12. Don't know what n is, but I do know my common difference. Okay, so from there, I can just solve an equation like I have done in all of my classes leading up to this one. So the 17th term of the sequence is negative 20. Okay, so they could ask you word problems, which I've been told that this is not the correct Harry Potter setup. But again, they ask you for when each of the movie tickets are sold, and they're basically just making it look a lot harder than it actually is. Because if you look at the actual thing itself, there's your sequence. You notice you're going up by 25 cents, and then it costs $8.50. They want you to find the fourth movie and so on. Okay, so looking at this particular example, you might have to graph it. Now you're thinking, why am I graphing a sequence? What does that even mean? All right. Well, if you also think about arithmetic sequences, you notice how we're adding the same thing each time. So a visual representation, if we are adding the same thing each time, should look a lot like a line. Okay, so let's say I wanted to look at 1. So that is my first term is 1. My second term is 3. My third term is 5. And my fourth term is 7. So if I graph that, you notice you have a line. If you notice from the beginning of today, we did this particular example. I'll just use that. If we use our formula, which our first term is 1, and our common difference, we're going by 2 each time. Combine like terms, that's exactly what happens. So if I would have, like I said, my board's off. Once I get down here, and this is what happens. So this is all real life that you're seeing all this. Okay, so if I actually have this up here at -1 like it's supposed to, if you notice my old school, this is my y-intercept, this is my slope, I'm doing exactly that, and so on. So it's just a visual representation. If you're adding the same thing each time, then you're going to have a linear representation of what's going on. Okay, and that is all for arithmetic sequences. Make sure you go back into Canvas and look at the assignment and go ahead and knock that out. And don't forget about office hours. Okay, thank you very much.